Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
Go above and beyond.
they become very good at what they do, but only
0.1%.
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
With Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius podcast. Our guest today is Chris Kulp. He's the John P. Graham Teaching Professor of Physics at Lycoming College. So we're going to talk about machine learning and what's called nonlinear dynamics and how that plays into how machine learning works. So welcome, Chris.
Hi, thank you, Richard. Thanks for having me for the show.
Yeah, let's always start out the same way. Tell listeners about you. What's your background and how did you get to where you are?
Yeah, absolutely. So as you mentioned, I'm the John P. Graham Teaching Professor of Physics at Lycoming College. I'm also a science fiction author. So I have two jobs, if you will. As far as physics goes, I teach physics at all levels. So courses for non-majors all the way up to like advanced physics courses like quantum mechanics. I also teach classes in machine learning and data analysis and things like that. And when it comes to research, my research sort of emphasis are, as you mentioned, in nonlinear dynamics and machine learning and complex systems modeling, which we can talk all about, of course, in the interview. And as a science fiction author, I write both space opera and dystopian science fiction. And I like to try to explore themes of sort of, human identity in sort of societies of high technology or space travel and those kinds of themes. I also write about, AI is usually a part of my novels as well in some form or another.
Yeah, I'm starting to ask all the people I interview about AI. What has changed in the past couple of years that's allowing AI to suddenly have this renaissance of this explosion? Is it just another layer of, weighted factors and now we're getting these emergent properties, or why now AI is like so salient and so prevalent? What's changed?
Yeah, so AI has gone through a lot of different phases over many decades, honestly. So some of the first, algorithms for neural networks, you can date back to the 40s, 50s. And so the field has historically had like these growth spurts and then these lulls. And a lot of times they correspond to technology. Graphics cards right now are highly parallelizable. They're relatively inexpensive as long as the price hikes don't go up, right? Demand goes up or whatever. But we have, really good graphics cards where a lot of these calculations can be done on graphics cards, which are highly what we call parallelizable, And what that means is the card can do a lot of different calculations at one time, as opposed to having to do a calculation, wait for that answer, do another calculation based on that. So we see also, of course, improvements in things like algorithms. Like in 2012, we had improvements in something called convolutional neural networks to improve image recognition. So you might remember back in Facebook and like when all of a sudden you could start tagging your friends, or it would basically say, oh, is this your wife in this picture? Like, whoa, how did it know that? Well, you've been helping to train their AI algorithms is how they, by tagging your friends in your photos. So we see these fits and spurts, right, of based on either technological improvements or algorithm improvements. And, this won't be the last one. This is just one of a series. And don't ask me to speculate on what's coming up next because who knows, right? It's impossible to predict that.
Well, what's changed though is it the algorithmic change? Is it, again, there's just a lot more computing power, so you could have like 1,000-layer neural networks versus 100 layers, and now you're getting this better performance?
Yeah, I think both actually. Yeah, I said, like I said, the graphics card's getting better, but also, yeah, the concept of transformers is a new algorithm or newish algorithm. The idea of attention, where the algorithm can pay attention to particular parts of text or whatever. So I think what we're seeing kind of is this sort of, I'm trying to think of the word, basically this convergence of, in this particular situation, of a lot of different hardware and software developments to really have AI take off, in this particular, this generative text, these generative images, generative movies. We're really kind of in I think, a golden era right now of development for, like I said, hardware and software reasons. A lot of things.
And you think it's going to be like, I mean, do you think AI is going to follow like a Moore's Law trajectory, or are we going to tap out soon and we'll have to figure out something else? Like, where do you think it's at in this growth curve, and what does that look like?
It's a really good question. So everybody wants to know that, right? And everybody has an opinion. And every person you talk to will probably give you a little bit of a different answer. And so what am I thinking of? I think limits probably coming up in the near future would possibly be training data. So, I mean, right now, we don't really know necessarily all the details, publicly anyway, of how much of the internet, so let's say ChatGPT 4 is trained on, right? But at some point, we're going to run out of internet. So run out of books, right? Run out of things that we have produced. And then the question is, like what happens then, right? And it could be algorithmic improvements. And so there might be things like, when attention was developed, that was a big revolutionary idea that allowed, large language models to actually come into existence. So once we, quote unquote, I don't want to say run out of training data, because, new data is being produced all the time on the internet. But, once we have sort of saturated that training data, what's next, right? In terms of like how to train our data. Yeah. So it's always hard to say, because I don't like to be one of those people who's like, yeah, we're running out of, like, let's say, for example, training data, or running out of another limitation, is power, right? Is power consumption. And can we build power stations fast enough, right, to run the data centers, to train these models, which are really power hungry.
Hey, what's going to happen in the U.S.? Like, we'll need to build a lot of data facilities, a lot.
Yeah, and I've heard stories of, for example, certain power companies, like, Microsoft comes into an area and says, hey, I want to build a data center here. And the power company's like, no, because we cannot get you the power, right? We just can't. And that's why they kind of bought 3 Mile, like part of 3 Mile Island or whatever that deal was, to try to, like, basically, generate power so they can generate more complicated models. So I think we actually have some limiting factors in terms of training size, which is probably overcomable, like training size, power. But then again, power might be overcomable as well, because we're seeing things like DeepSeek, for example, that can do things more efficiently than we originally expected to be able to be done. So it's, boy, this conversation, and every time I hear it, kind of reminds me of discussions about physics in the early 20th century, at the turn of the 20th century, where you had people like Lord Kelvin writing, physics is over, and people telling their students, don't study physics because there's just details left. And then lo and behold, there's quantum mechanics and the whole quantum revolution. And then we had chaos theory come up in the middle of the 20th century. So I'm always hesitant to make these kinds of predictions, because I know the history too well.
Okay. That makes sense. So where do you see AI advancing right now? Mostly, it sounds like these LLMs, these interactive, like, chats, I guess you could say. Now they're talking about AI agents that actually perform basic tasks and all that. But what do you see over the next, since things are moving so fast, over the next 2 years? What's going to become available for use by, slightly techie interested people?
Yeah, that's a good question. I think what's gotten me interested right now in particular are some of these chain of thought models, which, roughly speaking, the AI shows its work, right? And its steps and its reasoning. Now, there's been some studies very recently put out, that when the AI is showing its work, it's not always being completely honest about all the work that it's showing. But that aside, I've been having a lot of fun with my students playing around with these chain of thought ideas. And I can give you a good example. Something we did in the class a few weeks ago. There's a theorem that we were working with, I was teaching my students about. It's called Stokes' theorem, but that's not really important. If you have any physicists, they'll be nodding their heads. Everyone else will be like, "Whoa, what's that?" But the point is that there's two sides of the equation. There's the left side and the right side. And Stokes' theorem gives you two different ways of calculating the same thing, and you have to get the same answer, right, with both. And so we had an AI. So we did a problem on the board, and then we had an AI, it was Gemini that we used, solve the problem. And it did it one way, and it got the right answer. And so then we asked it to do it the other way, and it got 2 times the right answer. And so then we prompted it in class, like, so shouldn't these be the same? And it responded, oh, you're absolutely correct. These should be the same. And I see my mistake. Let me show you. And it wrote out the mistake. And what it identified the wrong answer as the right one. And then in its chain of thought processing, it fudged a factor of 2 which was actually the correct answer. So it would match the wrong answer and both sides of the equation. And so it basically recognized, oh, this is not right. I think the wrong answer is the right one. It didn't know it was wrong, obviously, right? And so then in its chain of thought process, there's like this magical factor of 2 it's stuck in there. And so that you would get the wrong answer to match the other wrong answer. I think developments in these kinds of processes is what has me excited, even though this particular case was wrong, because I think it's going to help us collaborate with AI. If we can start to reliably understand the steps that it takes, then we can actually use this tool alongside of the scientists, alongside the AI, working together and understanding, how is it coming to this conclusion? And that can, I think, help, further research. So that's one of the areas I personally find most exciting is these improvements. And with the study I'd mentioned earlier that talked about how when these chain of thought processes appear on the screen, they're not always completely faithful to what the AI has actually done. I'm actually really excited about that study because now people are looking at this. We're starting to ask questions. How does the AI work? And a lot of times we don't know that answer, right? But now we're starting to care, right? We're starting to care. Like, well, how are these things coming to the conclusions that they're?
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
Oh, that's really good. So what has the recent boom affected every part of AI or only certain parts? It seems like, the LLMs, the large language models have been big time affected. They're answering a lot better. But what else do you see is improving because of this?
In my experience, I've seen the biggest improvements with the generative stuff. So the LLMs, the music and video generation. I'm less familiar with those two aspects, but I follow some tech podcasts and they're talking about, oh, these are getting better. They're still not great, right? But that's kind of AI in a nutshell. It's not always great, but it can be a good collaborator, right? One of the things that I talk to my students about how to use AI sort of ethically and just, for their own work is to allow it to have a conversation so that you can get out of your mental ruts. So I can give you an example with my writing, okay, as a science fiction writer. To make it perfectly clear, I do not write AI-generated text. I'm not copying and pasting from AI responses for my books. But, as I'm writing and, I'm 1,000 words into the evening of writing, one gets tired. And so one might be describing, oh, I've got a character blushing. And I'm like, oh my gosh, I cannot say again in this novel in an early draft that this character is blushing. So I can go over to something like Gemini or ChatGPT and say, describe someone blushing, right? And it'll give me a lot of difference. And all of them individually are usually not great, right? But sometimes I can look at that and I can say, oh, I can pull a little bit from that. Or I can read one of them and say, oh, that actually is getting me to think about this now instead. This is how I want to talk about it. So I'm not taking the output. right? What I'm using it is to basically just kick me out of a mental rut. And I find it both in my scientific research and in my writing super useful in that regard.
So I guess if you look at like the answer space, you might be the local minimum or local maximum, like trapped in this small neighborhood of possible answers. And what I think is cool about AI is it has the potential to show you the entire surface of the answer space. And you can see pockets that you never knew existed, you know?
Yeah, absolutely. In that regard, it can. But of course, the AI itself can get stuck in suboptimal local minima, if you will. And so that, it gets stuck into like this region. And if you want to explore more, you've got to get that AI you got to, sort of kick it out of that sort of stuck as well. So for both the humans and the AI, you have to be worried about, being stuck in that rut, if you will. But I think that's exciting. I think it's an exciting collaborator to work with.
Yeah. Good. I don't know. Like, so it seems like, with Google, remember when it came out, everyone said, oh, all the world's knowledge in your hand and, the bar is going to be raised and people are going to be doing all this stuff. And there are some that do that, but there are a lot that just like watch porn and Netflix and whatever. And, there's amazing technology there, but they don't take advantage of it. And same with AI. I have friends that use it like every day, for all kinds of stuff. Some of them maybe too much. And then a lot of people are like, yeah, I heard about it, but, they just don't care. So I'm guessing that AI will start to be used by a lot of people when you have like simple apps, like an AI app that has an agent in it that does X, Y, Z, schedules an appointment or whatever. And then maybe people will use it more just as like, again, for these specific tasks. But I don't see a lot of people sitting there talking to it, querying it, trying to figure it out, how to prompt better, that stuff.
Yeah. Well, the thing is, I think with AI is that we want to throw a wider net in what we're talking about. So all those people that you mentioned who are not querying LLMs right now, they're still involved quite, thoroughly with AI insofar as like limited machine learning. Like when they're on Amazon, that recommender, like, hey, you bought, this book, we recommend this book instead. That's AI. If they're streaming Netflix and, it recommends new shows. If they get an alert, a fraud alert on their phone for a credit card transaction, that's machine learning. That's all done by machine learning, right? So I thought really what we're seeing with AI is going to be ubiquitous. You won't even notice it's there. And that's good and bad, right?
Yeah, that makes sense. If you, I'm sure everyone asks you about AGI and what's the likelihood of it and all that. I don't know, I guess I see AI as like a series of idiot savants that are strung together to accomplish a task. But now they do see, working more independently and getting a lot more done under one system. Like, what do you see?
Yeah, that's an excellent question. Again, it's one of those questions where you ask 100 people, you'll get 100 different answers. Well, you'll have the true believers who do think that something like ChatGPT-4 is, a sentient thing. I'm not in that camp, by the way. And then other people who are like, this is, absolutely not. This is just, fancy curve fitting, right? And I probably, if anything, I'm more in that camp. But the idea is it sure does look like it's AGI, right? Like it does, it talks to you, and that is by design. It talks to you like a person. It makes you think it's thinking, right? I don't think it's thinking, I'll give you a good example. Melanie Mitchell of the Santa Fe, she's an external professor at the Santa Fe Institute, has been doing AI for a very long time. And she had a study recently put out where she basically posed the following question to generative AI model. Let me see if I'll probably get the exact wording wrong, but the idea will be correct. All right. Jennifer has 2 sisters. How many sisters does her brother Michael have? Okay. And so the answer is 3 because you need to include Jennifer, right? Michael has 3 sisters. But if you ask like Gemini, we did this in my class. You ask Gemini, it will respond with 2, at least as of the time of this recording, right? If by the time your listeners listen to this, who knows what it will say. Right now, it's not capable of that kind of, even though when we asked it to show its work, it had hints of understanding, especially we did one of their experimental thinking models. You could see in the experimental thinking model that it was kind of recognizing the fact that Jennifer was actually one of Michael's sisters, but it still produced the answer.
How do the reasoning modules work? Where's an LLM? Like, do you know?
Yeah, I unfortunately do not know. That's a bit beyond my expertise. I'm not a ML engineer. I use it as a tool for my work. I do code up some machine learning, some more basic machine learning models, things like random forests, support vector machines, a few basic neural nets with libraries and stuff like that. So I do train my own things. But when it comes to LLMs, I have some basic understanding of a few things, but unfortunately not that.
Right. Interesting. I don't know, what are the holes in AI that you see right now? It still hallucinates sometimes. It still doesn't or can't share its reasoning. I guess the troublesome thing is that sometimes it kind of tells you what you want to hear, that is only good.
It will straight out lie to you with a smile on it. And like, it will basically, like, this is, it answers with these human tics to make you want to, go along with what it says. But, hallucinations or just basically flat out error. I think hallucinations is a nice term for just error, right? It's just wrong. I, yeah, you make stuff up, right? Those bother me less than some more fundamental issues that I think need to be tackled. And this is with AI in general, where we're talking about, basic neural nets or even like support vector machines all the way up to these LLMs. And that's really getting a handle of what the training set is. What are we feeding? What's the diet we're giving these models? And is it a good diet, right? And I think that's something that we need to have a serious conversation about. And I think there's some people talking about this now of vetting training sets, right? And it's not necessarily where you have a quote unquote approved or disapproved training set. Like, I'm not trying to be authoritarian here, but what I'm trying to say is understanding, like, what are the limitations of the training set and putting that in the context of what is the output of the AI, as opposed to just, dumping a bunch of data into it and then saying, well, that's the right answer because that's what the AI saw. I think it's
Well,
valid.
you need a little bit of time to integrate and then you can use it.
Yeah, well, also the quality. So, for example, is your training set representative the types of predictions that you're wanting?
Oh, what do you do with outliers? And what if the outliers are not uniformly distributed high and low, but more high or more low? I mean, there's just a lot to it. Like,
Yeah, you're absolutely right. Or think about self-driving cars, right? We're pretty far along with self-driving cars, but there are just rare events that are in the we call the long tail, that are just very infrequent, that you just don't see enough to, train an algorithm on. Of course, humans are the same way, right? I mean, how many times do you get the classic driver's ed scenario where the red bouncing ball comes out in front of your car, right? That doesn't happen very often in the real world. It's an individual driver. And so what do we do as humans? Well, we make the best decision that we can given the circumstance that we're in, right? That's what we do. Sometimes that is a tragic result. Sometimes it's not. And that's what these machine learning algorithms are going to do. If it doesn't have enough of that sort of that element in the training set, it's going to start making random decisions. And so what we, I think, to do when we understand these training sets is, where is the sparsity of those training samples? And then, are we tweaking the algorithm?
And what does a complete and good quality data set look like? What does it have in it that a lopsided or crappy or poisonous data set would have?
Yeah, it's a great question. I think that's going to definitely depend on the situation that you're in, right? The types of things that you're looking at. So I think what we really need to ask first is, what is the problem that I'm trying to solve with the machine learning algorithm, with the AI? Okay. And opposed to basically just saying, here's a hammer, everything looks like a nail, right? We want to start problem first. This is what we do in my laboratory as well. Like, so what is the specific problem that we are trying to solve? And now we're going to train this AI, and we train this AI, and we need to make sure that this training set has the full spectrum of things that we could possibly see to the best of our ability. You can't do it 100%, right? There's no, perfect batting average here, but you want to take pains to make sure that you have representative samples that are representative of the situations that the AI is going to encounter. Know what are those sparse situations, so that when your AI is applied, when your model is applied to that particular case, oh, you know what? We're now using it to look at, I don't know, $1 million expenditure. I haven't trained my fraud detector on $1 million expenditures yet. Okay. So that should be red flagged and then should be sent to a human. It says the AI said this. However, we know that the AI isn't well trained in this situation. So person, please inspect us. And that's where really, again, thinking about AI and the machine learning algorithm as a collaborator with a human workforce, as opposed to a replacement.
Like a sense, like chess, they play with Deep Blue or whatever, Stockfish, those kind of engines. And the best players now use those engines along with their knowledge. They crush everyone else. They do really well.
Yeah. And I think, that's going to be true in a lot of knowledge creation fields where, scientists will be working with an AI. Like you just collaborate with an AI, right? Like it's not even special. Like at some point it won't even be special. It'll just be like, yeah, I'm thinking about this new project and I went ahead and started having conversation with Gemini or ChatGPT or, whatever your favorite LLM is or whatever's your appropriate LLM, making sure that your LLM is tuned to the kinds of problems that you're interested in, right? Because, that will be better. I think the smaller, more focused models will be better in those situations than your
what are some of the terms? I've heard of tuning. What is that? And then there's another term. I forget what that is, but like if you just, let's say, I don't know, you wanted to discuss Elizabethan poetry with the AI and you loaded up, I don't know, 500 poems on it. What would that be? Would that be called tuning it or what is that? Can you overdevelop a part of the AI so it skews it to where it can't answer you properly anymore?
Yeah, sure. I think that would definitely be possible. I mean, I know in more traditional sort of machine learning topics, some of the things that I teach my students, even simple models like various regression models and things like that, you could what's called overfit. And so that means is the model parameters are too dialed into the training set. Think of like a kid's connect the dot.
It's like training how to play baseball, but everything they throw to you is like underhanded and it's like a softball pitch. So you never get any real experience with tough stuff.
Yeah. Or I tell my students, like if you're studying for a math test and all you do is study the homework problems the professor assigns. So if the professor gives you a homework problem, like copies a homework problem, puts it on the test, you're going to do really well in that test. But if the professor gives you a slightly different problem and all you've done is memorize the homework problems, then you're not going to perform as well because you have that mental flexibility, right? Because you're too tuned in, you're too dialed into that particular problem set that you've memorized.
Is there a setting that's called that? Like, or again, is it just overfitting data? Like, what is it to you for an AI to be very flexible?
So you want to add a little bit of what they call bias in there. You can penalize certain variations. At this point, we're probably getting a little technical, but essentially keeping the model that you're using to be less complicated. So, for example, if you might have a curve that looks like a hump and, you could use a polynomial, fourth order polynomial, so x to the fourth to fit that plus some other terms, but that might be connecting the data points too closely. So you might say, you know what, the parabola doesn't connect all of the dots, but it gives me like an average-ish of all the dots. It gives me the trend. So that now when I see a novel situation I haven't seen before, it's going to perform a little bit better because it's just not so focused on the exact training data that you have. So a little bit of error is a good thing because it gives flexibility. It gives the model flexibility.
So what is the, I guess in the next year, are there any major developments that you see coming you're waiting for?
Oh, that's a good question. Boy, it's such a fast moving space. A year could be like a decade, in the short term, I think what's like I said, what's got me excited is some of this work that's maybe not quite as sexy, but the smaller parameter models that are more efficient, that are, again, specialized to help, researchers in, let's say, medicine or science or whatever the case might be. Development of more of those has got me interested. The chain of thought, for the reasons I talked about earlier, has got me interested. I'm also really interested in the more efficient. Now, I'm not an expert in making these things more efficient, but I'd watch and listen to some of this stuff. And that's got me excited too, because one of my concerns is the environmental impact of just burning all this electricity to not just to train these models, but to query these models too, right? Because that's an expensive process. You're reaching out to a data center is doing some math and sending it back to your computer. And, like streaming music and streaming video, these are all electricity data intensive processes that, have an environmental impact. So I would love to see, and I'm hopeful for more efficiency improvements in that direction.
Okay. What's, I don't know, like today, what is making the best AIs? Like if you had an AI to assist you with a given task, what would make it just amazing where it has everything you want? What kind of features or things would it have?
Oh, that's a very good question. Going to depend on the tool that I want to use. So I find myself using three tools. I find myself using Anthropic's Claude, OpenAI's ChatGPT, and Google's Gemini. And it really depends on what it is I'm working on. So like if I'm working on fiction, I like to often use Claude. I find that Claude often gives me some really nice alternatives to things I'm trying to say. Or, if I want to, get a character, put a character into a situation, I will maybe chat with Claude a little bit. I'm thinking about this. What are some options here? And I think it just kind of gives that more literary spin. Again, it's nothing I would ever copy and put into my own work. I don't think that's appropriate, but I think it's just creative in that way. When it comes to code generation, so when I'm producing code, I find myself leaning on Gemini and ChatGPT a little bit more. Gemini purely because it doesn't kick me off. Gemini doesn't tell me, oh, you've reached your limit for the day because I'm too cheap to pay for any of these things. And so find that, to answer your question, one of them is just don't kick me off, right? But the code I find is pretty good. It's not, again, like the fiction. It's not always the case. It's rarely the case you can just copy and paste from scratch. There's some simple coding things that you could absolutely do for perfectly fine, I think. But some more complicated coding things, especially with like the agent-based modeling I do on complex systems, you want to have a conversation with it, and it takes multiple sort of rounds of querying to get that out. But yeah, I mean, that's kind of what I'm looking for is depending upon the task. I don't know that there will be such a thing as the one perfect AI, because I think what we really could stand to work with are things that are specialized for given topics. Something to help the writer, something to help the coder, something to help the nonlinear dynamics person, right? As opposed to like this one uber AI that you go to and can do everything.
Yeah, with stories, what I learned is now what I do is I'll write a whole story and I'll put that into the AI as a prompt. And the AI will clean it up and make it look nice, Like it's like me, but it puts makeup on me and makes me look good and dresses me up so I'm not a slob. So that's what I see like the best use for it, at least in terms of writing, is so far,
Yeah, I usually don't use it for that. Like I said, for me, it's mostly that rut, right? Getting out of that, having that conversation, stimulate creativity. I'm very much about stimulating creativity with AI. But I do use it to check things like grammar. And again, you have to be careful with it. But, for a quick and dirty, like, hey, is this grammatically correct? You can scan over it. And if it doesn't look suspicious, like, okay, I'll move forward with this and I'll check this with my editor later, right? Kind of just gets me over that, like, just gets me kind of moving forward for sure. It does a pretty good job of summarizing texts, a lot of times. But again, like I tell my students, we're still needing to check everything it puts out because, it does produce errors. And I think it's just very important to just, proceed with caution when using it, right?
Yep, true. Other modules that are coming out, so we get reasoning modules like LLMs. What about GANs, the generational adversarial networks? How can those be used to improve an AI?
So I have a limited understanding of GANs. This is not something I do a whole lot of, but my understanding is they kind of play against each other. You have sort of like two AIs like fighting against each other, if you will. And so, and we see this with was Alpha Zero for the Go, learn how to play Go by playing against itself, right? And I think what you get there is you can sort of more quickly, you can train these things maybe without giving it so much input.
What if you did this? Let's say there's I'm just making this up totally. There's 10 world-renowned scientists that, specialize in nonlinear dynamics, you being one of them. And I take my AI and, I say, all right, here's a problem. And I put it in there and I ask it, I say using, the thought patterns and experience and all that of, Chris Kulp and, I don't know, Bob Smith. Critique this and help me find a solution. And then you do the same thing, but you use Joe Jones and Jane Smith and, Amy X and all that, like 3 other people to come up with a solution. And you keep kind of rotating through these top minds and what they would think and answer and say and try to approach the problem, 9, 10 different ways with all these permutations and put it together to see what answers you get.
Yeah, now you're using it as a collaborator, right, in a sense, and you're having it sort of virtually collaborate. So there's a couple of issues potentially with this. I would say that you would still need to know something about the field that you're working in. You couldn't be a novice, right, because you have to be able to interpret the outputs to make sure that it's actually pulling together things correctly, right? The other thing, too, is making sure, and we talk about ethically training these things, did I give company Y permission to train, like to be me, right? Or at least to be a simulation of me. And that's something that, artists are really, concerned about right now, and rightfully so. So we talk about, thinking in the style of Chris Kulp, or thinking in the style of, Einstein, or name a scientist. I think there's an issue there we need to worry about. But if we put that issue just to the side and just say, oh, suppose we had all the rights, right? And then it's fine. Then again, you still have to be careful because, as we talked about earlier, hallucinations still happen. So you still can't be just pure knobs, right? But with that being said, you don't necessarily have to be pro expert either, right? So basically what this is helping do is make these things more accessible.
Okay. Is there any, I don't know if you have previews into how some of the AIs are going to work, but is there anything that the AIs are doing that just blows your mind? You're like, I can't believe this, man. This is crazy.
Yeah. So I can give you another example from my classroom. We were solving a problem and we were wondering, how would if AI can do this? And messing around with some stuff. And then, I don't know, sort of off the cuff, I said, you know what, let's just ask it something completely, upper level physics and see what it can do. And the problem is you have think of like a disc that's spinning with a pendulum stuck to the end of the disc. And you want to we asked the AI to create the equation that describes the motion of that pendulum. And so that's a sophomore, junior level physics problem. Okay. And sure enough, it solved it correctly. Yeah. So then I made this offhand comment. I'm like, you know what? I have a feeling it probably can't interpret the terms of this equation. In other words, like this term is the term that represents the force of gravity. This term represents the spinning of the disk, so on and so forth.
Yeah.
And one of my students goes, well, why don't we find out? Like, yeah, let's do it. So we just then said, can you interpret your answer? And what blew me away was it could. It went term by term of that equation and said, this is the torque due to gravity. This is the torque due to the spinning disk. My students and I just were looking at the screen with our jaws dropped. And that was something that I was not prepared for it to be ready to do. I don't know why I wasn't prepared for it. I don't know why I wasn't expecting it, but it just was one of those moments that it just blew me away that it was able to do that. So yeah, that's an example. What stunned me was the interpretation. The solving, okay, fine. Maybe it found that problem in a training set somewhere, so it's seen it before. But the actual interpretation, that was what really, I was very impressed with.
Okay. Well, it's funny. They always say AIs are like black boxes, the inner layers and stuff like that.
Yeah.
Can they train an AI to say, hey, figure out what's going on inside this other AI?
Oh, that's a good question. I don't know. And, I will be I'll be the scientist answer here. I think there are some things that people are definitely, and again, this is a little bit outside my expertise, but people are starting to, answer the question of how do these neural nets make decisions and things like that. It's still really early on in this process. So we could train an AI to learn how another AI works. That would be wild. And it might be done. Unfortunately, I just don't know. But I'm definitely going to look into that because it sounds like something someone's tried, right? That just sounds like something somebody's done. And I just don't know.
Okay. And I know I kind of asked you before. I don't know if we got the answer out, but do you think AGI is possible or or not really?
I don't know. I think that, and I'm going to be like the scientist that kind of waffles, right? I don't know if we understand what consciousness is for humans, right? And so it becomes hard to say, can we then identify, AGI? Will we be able to do that? It's just the question too, like, when searching for extraterrestrial life, will we know life when we find it, right, out there in the universe? Will we know a conscious AI when we come across it? And possibly not. I think we need a better understanding of what makes us first. And I think asking questions like the one you just asked helps with that, right? I think there's a place for studying AI to help us understand ourselves. Just like with bipedal robots, like, you don't really appreciate how hard it is to walk on two legs until you try to make a robot do it, right? And so I think it's the same thing. Will we have AGI one day? Sure. Yeah. But that's pretty far away. I don't think we're anywhere close to that. But you know how science works. All of a sudden you think you've got the answer and plop, the next day it's right there in front of you. That's the crazy thing about science.
Definitely. Well, very good. Where can people learn more about AI and, like a simple way that where can they understand it? And if they want to take a course, what might be a good initial course for them to take?
Oh, there's a lot of courses online through YouTube that you can do. I can tell you how I got my start, and some folks might be interested in this, but Andrew Nigg he used to have a Coursera course. I think it's still out there. And this was many years ago. But a lot of that stuff that he covers is like just foundationally solid. Like if you want to really get into like the basics of machine learning, then jump into the more complicated stuff. That Coursera course was great. I think it was just called Machine Learning, Introduction to Machine Learning or something like that. I'm sure.
Like Andrew Hager or something, yeah.
NG is his last name. I think it's terrible. Yeah. And I'm terrible at pronouncing names. People say I can't do math. Well, I can't pronounce names. And, but he had a course, I'm sure it's been updated, which I got my start with, really good. And then there's a book I would also recommend. It's called Hands-on Machine Learning. And Geron, Geron, is the author of that book. And that is I actually use that book when I teach my applied machine learning course. There's a lot of great code examples. There's a really nice GitHub repository for it. And it goes through and just basically, again, it starts you with things like linear regression, logistic regression. These are the rock solid. If you want to understand issues of machine learning and AI, you want to understand these things because these things have your cost functions. These things you can talk about true positives, false negatives. You can talk about precision and recall and just get a real grounding, like a foundational understanding of what's going on before jumping into the more complicated stuff.
Okay. Well, very good. Well, Chris, thanks so much for coming on the podcast and explaining. I know it's still amazing and weird and inexplicable, but thanks for trying.
Yeah, thank you for having me. I really appreciate it.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.
Positives, false negatives. You can talk about precision and recall and just get a real grounding, like a foundational understanding of what's going on before jumping into the more complicated stuff.
Okay. Well, very good. Well, Chris, thanks so much for coming on the podcast and explaining. I know it's still amazing and weird and inexplicable, but thanks for trying.
Yeah, thank you for having me. I really appreciate it.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed. This is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.